Okay, what did the A tell me in vertex form? That's the number multiplied in front.
If it opens down or up.
So it tells me if it opens up or down.
And if it's compacts or I don't know the word to use.
So first let's stick with opens up or down, and then we'll go there. How do we know if it opens up or down? If A is positive, it opens up. If A is negative, it opens down. Okay, that's the first thing it tells us. The second thing it tells us is the graph stretched or compressed? So how do we know if it was stretched or compressed?
If it's a decimal,
It's going to be compressed.
Correct.
If it's a bigger number, it's going to be stretched.
If it's bigger than 1, we're stretching it. If it's a decimal, we are compressing it. Okay?
What about a fraction? Is that the same thing as?
Fraction's a decimal. So as long as it's a fraction that's less than 1, right? Like 1/2. But if it's like 3/2, 3/2 is 1.5. It's a stretch.
So it's like an improper fraction?
Correct. Correct. Improper fractions would stretch it. Okay, does A tell us anything else? No, that's the only two things we know from A. It opens up or down, or it stretches or compresses. Okay, what else does this graph tell me with the H and the K?
H says where it's going to start the x-axis.
So H moves me along the x-axis, left or right. K moves me up or down on the y-axis. So the vertex, and what does the vertex mean?
Where the graphs, or where
The lowest.
It's either the lowest point or the highest point, whether it's a minimum or a maximum value. That vertex occurs at HK. Because we shift left or right, H, and we shift up or down, K. That's why this is called vertex form, because it's very easy to identify the vertex that is at HK. Now, what else do we know? Once we know the vertex,
line of symmetry.
which we call, you're close,
Axis of
the axis of symmetry.
That'd be x equals h.
It is going to be, it's the equation of a line that is x equals h. Because remember, the h moves me left or right. And so whatever that h is, that's where my axis of symmetry is at. So that's kind of a lot of information from a graph that I can know just by looking, without even having to graph it. I can identify if it opens up or down. I can identify if it's been stretched or compressed. I can identify where the vertex is at and where my axis of symmetry is. That's really a lot of information.
It is a lot of information.
It is. Well, today we are going to be moving from vertex form, which tells me all of these things, to standard form. So here is the standard form of a quadratic equation. F of x equals ax squared plus bx plus c. It's still quadratic because it's x to the second power. Just like in vertex form, I have x to the second power. All right, so what's really the difference between vertex form and standard form? Well, vertex form has been factored. You see how this is factored to be x minus h times x minus h? That's a factored form. Where ax squared plus bx plus c is not factored. But we learned last chapter some ways that we can factor this by doing the a times c method. Okay, that's coming not today, but next chapter when we get there. So just know that's where we're headed. Okay, so why would I want standard form when vertex form tells me so much about the graph? Well, two reasons. Standard form can tell us some more things about the graph. And most of our equations that we see are going to be in standard form. They are not going to be in vertex form. If they were in vertex form, that's very nice. It's really great. We know how to move it. It's pretty easy. Okay, but most of our problems will be in standard form. So let's look here. I've got three graphs that I've already put in my graphing calculator for us. We can see here this is the function f of x equals negative 2x squared plus 4x minus 3. Here is the function negative 2x squared plus 4x minus 1. And here's the function negative 2x squared plus 4x plus 1. So what's different about these three functions? The only thing that's changed in every one of them is the
K. Or what?
The C.
I don't know what
the
it's called.
C.
C, oh, it's
Remember,
the standard form.
we're in standard form
I
now.
didn't look it up.
Ax squared plus bx plus c. So the A term and the B term are the same in all the graphs. All that's changed is the C term from 1 to -1 to -3. Now, do you notice where that appears in the graphs? Can you see the C term showing up? Hopefully you can, because they're kind of giving you a little hint there too. Where is the C term occurring at?
On the y-axis.
So my C term is the y-intercept. You know how before we talked a little bit about y-intercepts and how we can use them? Here is how you use the y-intercept in standard form. Whatever the C term is the y-intercept. So that's something we're going to add to our toolbox. We'll know if we're in standard form. So in standard form, C is the y-intercept. And again, an intercept is just where we cross the y-axis.
Are we going to be doing examples of these problems today? Like on our own?
Yeah, we're going to be doing some. I've got to teach you a little bit about what all we can learn from it first. And then we're going to work some on our own.
Do we get homework today?
Yes, you get factoring sheet today. So the C value is the y-intercept. That's where it crosses the y-axis. Does anybody notice anything else about all these graphs? And you may or may not. They all open down.
They all have the same first two numbers.
Right. So what do you think lets me know if it opens down or not? Opens up or down?
The one in front of
The
the
AX.
X.
It's still the A term,
Yeah.
right? You notice in both these forms, we use the same letter A because that number is the same in either one. So the A term here that tells me does it open up or down, is it stretched or compressed, is the same A term here that's in standard form. So because it's negative, it's going to open down. Because this is a 2, I know the graph has been stretched down. Right? All that still applies here. So the A term still tells me, so let's add that to our toolbox as well. Sorry. This is not as easy as it used to be to move this text. So in standard form, C is the y-intercept, and A still tells me if it opens up or down, and it still tells me if it's stretched or compressed. Stretch, that's not how you spell stretched. Stretched, compressed. I'm going to abbreviate because I'm out of room. So the A term still tells me, that's an arrow. A tells me, does it open up or down? And is it stretched or compressed? Now, one thing I want us to think about is why is C the y-intercept? So this is something that I really focus on a lot in pre-cal. We haven't done it as much in Algebra 1. It just really hasn't been as relevant. But think about all these y-intercepts. What is true of every y-intercept of the parabolas here? What's the same for every y-intercept?
X is 0.
X is 0. Absolutely. Y-intercepts always occur on the y-axis. And at the y-axis, our x value is always 0. So think about this. What happens if I plug in an x value of 0? Because I can do that. I can choose any x I want to. If I plug in 0 for x, what happens to these two terms? The negative 2 times 0 squared is 0. 4 times 0 is 0. So you see, when you plug in 0 for x, that's how you find a y-intercept. Plug in 0 for x, what's left? Only the c term. If I plugged in 0 for x, what would be left? Only the c term. So when x is 0, y is negative 3. When x is 0, y is negative 1. You seeing that pattern? That's why the c term tells me the y-intercept. Because if I plug in 0 for x, I'm only going to be left with that c term. So in the standard form of a quadratic function, ax squared plus bx plus c, where your a term cannot be 0, c is the y-intercept. We just learned that. Okay? Next, the axis of symmetry. That's cool. That's something I want to know. Because I know the vertex happens on the axis of symmetry. The axis of symmetry of the graph occurs at the line x equals, and here's the formula you're going to have to use for the axis of symmetry. So you want to write this down. When I'm in standard form, we can find the axis of symmetry by using the formula. X equals negative, so there's a built-in negative, b over 2a. That will give me the axis of symmetry.
It's always going to be 2a.
It's always x equals negative b over 2a. When we get into factoring our quadratics next chapter, I will show you where that formula comes from. Okay? But we're not ready for it yet. All you need to know right now is that's how I can find the axis of symmetry.
Look, this is just gonna be a long process.
It is a little bit more work. Now that I know where the axis of symmetry is, what always happens at the axis of symmetry?
The graph starts.
Well, the vertex. Right? The vertex is always on the axis of symmetry, whether it's a maximum or a minimum. So because of that, if we know where the axis of symmetry is, we know the x-coordinate of the vertex. So if we know where the vertex occurs, again, the vertex is an ordered pair, then we can plug in the x value to find the y value to have that ordered pair where the vertex is. So again, it takes a little bit more work when it's in standard form, but I can find out all the same things that I knew when it was in vertex form. Plus, I can find out the y-intercept, which is cool. Here's what it's going to be. We're going to graph the function f of x equals 2x squared plus 4x plus 3. Here's how we're going to graph it. Don't put in your graphing calculator. Okay? That is a tool. You can always use it to check. But right now we're wanting to learn how to do it without graphing it. Just like when it was in vertex form, you could kind of picture what the graph was going to do. I want to do all the same things here when it's in standard form. 2x squared plus 4x plus 3. So here's going to be our list of things we're looking for. I want to know, does it open up or down? We're not going to answer it yet. I'm going to want to know, does it open up or down? I'm going to want to know, is it stretched or compressed? Or neither. Right, it could be neither.
Could just be one.
I'm going to want to know the y-intercept. That's where it crosses the y-axis. Right, one would be, sorry, I wasn't listening. If A was 1, it wouldn't be stretched or compressed. Right? It would be in its normal state. Opens up or down, stretched or compressed. Where's the y-intercept? I'm going to also want to know what is the axis of symmetry. Where's the vertex? That's all the things that we know how to do right now. Next chapter, we will learn where the x-intercepts are. Okay? But not yet.
You gotta quit telling stuff that just makes us dread it.
No. It means you're going to get to factor again. So that's a good thing. Everybody get fired up about factoring.
Woo!
So first, does the graph open up or down? How do you know?
It is positive.
Because the A term is positive. 2 is positive. Therefore, I know it opens up. Questions about that part?
Nope.
Is it been stretched or compressed or neither? Stretched. How do you know?
Because the number's above.
Because the A term is bigger than 1. So I would say here it's been stretched by 2. Everybody good with this part? What's the y-intercept? Where does it cross the y-axis?
0, 3.
It crosses the y-axis at 3. Remember, it's the C term. And again, the y-intercept is an ordered pair. So the x-coordinate is 0. The y-coordinate is 3. Everybody good with that part? Right? Those three are just looking and identifying. Okay, here's the new part. Axis of symmetry. So remember, the axis of symmetry is the one that cuts the parabola into 2 equal parts. So we can find it by plugging into the formula x equals negative b over 2a. So what would that be this time? That would be negative
Negative 4.
4. 4 is my b term, right? Remember, standard form. That's my b term. Negative 4
And
over
2
2 times a, and the a term is 2.
Okay.
So what is 2 times 2?
4.
4. And then negative 4 divided by 4 is negative 1. And again, you can plug that into your calculator if you are unsure. But the axis of symmetry occurs at x equals negative 1. Which means what? The graph got shifted left 1. Right? If I think about vertex form. It got shifted left 1 because the axis of symmetry is now at x equals negative 1. Questions about how to find this? Axis of symmetry. Everybody's good there? Now, find the vertex. So the vertex is an ordered pair. I know the vertex happens on the axis of symmetry. So if x is negative 1 at the axis of symmetry, the vertex happens at negative 1. Because it happens on the axis of symmetry. And now all I need to know is, what is the y value when x is negative 1? So what we're going to do is take negative 1 as my x and plug it in to my function. Okay, so I'm going to need to do a little bit of scratch work. I'm going to do it on the board because I think it's going to be a mess if I don't. So this is going to be, I'm plugging in negative 1. Does everybody see why I'm plugging in negative 1? So this is going to be 2 times negative 1 squared plus 4 times x, but x is negative 1 plus 3. Can everybody see that marker okay? I'm going to switch. I'm just going to copy it again. So I've just plugged in negative 1. Everywhere there used to be an x, I've plugged in negative 1. In your calculators, you can put this in there, just like it is. Okay? So if you struggle with algebra, if you struggle with simplifying,
What if you're just slow?
plug it in, just like it is. Okay? I'm going to keep working it out because I don't have a calculator up here. But you guys, once you get here and it's all numbers, you can plug it in. You just need to make sure you put -1 in parentheses when you square it. Right? You need to make sure you do that. So for me, order of operations, -1 squared is 1. 4 times -1 is -4 plus 3. 2 times 1 is 2 minus 4 plus 3. 2 plus 3 is 5 minus 4 is 1. So if you plug this in, you should get 1. I need to go through the steps more slowly. I need to help you guys put this in your calculator. Did anybody put this in and not get 1?
I just have a question. What about the F?
So that's function notation. We never do any math with the F. This is why we practiced this at the beginning of the year. And y'all hated it then too. Y'all acted like you didn't want to learn it then. We just plugged in -1 for x. F of x is just a fancy way to say y. It is a function, but it just means the y value. So when x was -1, that's what this is saying. When x is -1, my output was 1. So y is 1. That's all it's saying. But this is just the way we write it, is in function notation. F of x means the same thing as y. So I plugged in a -1 and my output was a 1. Everybody was able to get that? Is everybody good with this slide? Now we're going to take all this information and we're going to sketch a graph. Okay? We're going to sketch a graph. Okay, so let's go through everything we remembered about our graph. We know it opens up, right? So I always put myself a little note here. I know the parabola is going to open up. So I put me little arrows, know it goes in that direction. Okay? Next thing I would graph, the axis of symmetry was at x equals -1. So I'm going to go to where x is -1, and I'm going to put a dashed line, right, like we did yesterday, for my axis of symmetry. Is everybody good there? Next thing I would graph is the vertex. We know the vertex occurred at -1, 1. So I'm going to go left 1, up 1, put my vertex. What else did I know? I know the y-intercept was at 0, 3. And because it's symmetric, right, that's what the axis of symmetry means. If it goes through 0, 3, it also has to go through -2, 3. Right, because of symmetry. It has to be the same on both sides. So now I have enough information, I have enough points to get a general shape of the graph. Again, the things I would be looking for if you had to do this by hand. I'd want the vertex. I would want the y-intercept, the axis of symmetry. It would need to look like a U, right? Not a V. When you draw it, do not make it a V. I'll count that wrong. I would also want arrows at the top. It cut off one of my arrows, letting me know this goes up in this direction forever. Wow. Those are the key characteristics we're looking for. Yes.
Where's that third point? How'd you get it?
This point?
Yeah.
Because of the axis of symmetry. So, because this point was 1 away from the axis of symmetry, then because it's mirrored, there must be another point that's 1 away. That's the only reason. Yes, if you want to think about it as yesterday. Remember, my A value was 2, right? Which means it got stretched by 2. So we normally go right 1, up 1. So because it was a 2, we're going to go right 1, up 2. That's where that point is. So if you want to connect that to it. We went here because we knew it was the y-intercept. We didn't actually use the stretch or compression yet.
Think that's coming?
It might, depending on how far away the y-intercept is from the vertex. It might. Now, if you felt like you didn't have enough information for the graph, like if you thought, I still don't know, I want some more points, what could you do to find more points? Just like we plugged in 0 for x, and we found the y values, just like we plugged in -1 for x, and found the y value, like what we did over there. You could plug in 1 for x. If I plugged in 1, you would find the y value should be 9. Right? So you could find another point. You could say 1, 9 should be on the graph. And then its mirror image would also be on the graph, which would be -3, 9. So you can get as many points as you want if you're not comfortable with just these 3. All right? You can always pick x's, plug them in, find their y. Okay, so let's go through all the steps here on A. On A, does it open up or down? So it opens up. I'm going to make myself a little note here. Opens up. Let me do like this. That way we know the parabola looks like this. Right? Opening up. Was it stretched or compressed?
Neither.
It wasn't. The leading coefficient's a 1. You could write stretched by 1, compressed by 1, but really nothing is happening. So I would just say no stretch, no compression. Okay, we found the y-intercept was at 0, 4, which means you should have a point here at 0, 4. We should find the axis of symmetry is -b over 2 times a. So x equals -2 is your, nope, I'm an idiot. X equals -1 as your axis of symmetry. You see how I can make a mistake? It's easy, all right? It's not hard to make a mistake. X equals -1 is my axis of symmetry. Draw it just like that. And then if I plug -1 into the function, if I need to go through that process, I'm going to because I've seen a bunch of mistakes. This is going to be f of -1 equals, every time you plug a number in, just put it in parentheses. Okay, that's going to be a good habit for you. So put -1 in parentheses, squared, plus 2 times -1, plus 4. If you put that in your calculator, just like this, you should get a y value of 3. Is that right? 5, 3, 3, 1 minus 2 is -1 plus 4 is 3. So it should be -1, 3. So then I've got this point, -1, 3. I also have this point because it's reflected over the axis of symmetry. And I can connect them, make it be a U, and give me arrows. What do we think? Questions? Any part that you need me to go over again?
9.
Okay. B part, does that open up or down?
Down.
Down. Because it's negative. So I know it's going to open down. Stretched or compressed? It's going to be compressed by 0.75. Again, I'm just making myself little notes because I don't have a lot of room, okay, on my paper. You should have more written out than I have written out. Any questions about opens down or compressed? Is everybody good with both of those? Next, where is my y-intercept?
0, -4.
It is at 0, -4. Right, it's always this C term. So I know this is going to cross the y-axis at -4. Okay, next I need to find the axis of symmetry. So x equals -3 over 2 times -0.75. Boy, I'm going to have to give myself more room. Give me just a second. I'm going to rewrite that. X equals -3 over 2 times -0.75. Can you guys see that okay?
Yes.
One thing I saw a bunch of people did, they left out this negative. Right? If A is negative, you have to put it in right here. It has to be -0.75. So again, if I put that in my calculator, I'm going to get x equals +2 as my axis of symmetry. And then to find the vertex, I'm going to plug 2 in here. So what's that going to look like? G of 2 is going to be equal to -0.75 parentheses 2 squared it plus 3 times 2 minus 4. Or you can put in your calculator just like that. If you do, you should get a y value of 1.
I got negative.
I got negative.
I got negative.
That's what I said, -1.
Okay.
Y'all just weren't listening.
I still don't think, I mean, I put it like, gravity like in my calculator, it showed a straight line, but.
You probably messed up. I can look at it.
but
2, -1 will be here. My axis of symmetry goes through the vertex, which means I have another point right here. Right, so I can keep them equally spaced over that axis of symmetry. And then again, this opens down.
That's what I got on my paper, but like, when I, to double check,
You put something in wrong. You put something wrong, I promise. You didn't have the exponent. If it was a line, you didn't have second power. I promise. X to the second always is a parabola.